Alrighty, the dynamics, the force balance, and the front. And I'll try to draw a little sketch of actually what creates the frontal flow is indeed a pressure gradient, and the pressure gradient comes from a sloping sea surface. Okay, so you have a pressure gradient in the frontal zone, which is shown here. So on one side, the sea level is a little bit higher compared to the other side. In western boundary regions, it can be up to 50 centimeters difference on a horizontal distance of 10 kilometers. All right. So you have a pressure gradient going into one direction. You get an opposing Coriolis force. That process lasts longer than a day. And then, so you get the frontal flow is the flow that runs along the front, geostrophic flow. It's shown here for the northern hemisphere, and the southern hemisphere it would go into the opposite. So you get actually flow which runs along the front and not across. Okay, so and if you are some particle or some float, you will be moved with that flow along the direction of the. So, as I said before, the frontal flows become dynamically unstable generally, and they produce, the first thing they produce is something that we call a meander. That's shown here over my head. Meander is just, instead of having a straight path, you have sort of a curved path. And then the extreme case is the formation of eddies, and eddies are circular. And you can already see here that eddies are actually fronts, but circular fronts. So the geostrophic flow runs around these features. Okay, and that can actually maintain eddies for a very long time. All right. So I think now on the next slide, I hope, comes an example. I'll give you an example of a front. But let's see. Let's check that out.